Hi dear students, let's start discussing about the other concepts of the chapter, matter in our surroundings. In the previous video, we covered about the characteristics of matter and characteristic of particles of matter. Particles are nothing but the molecules which are actually the building blocks of matter. In that video itself, we got to explore ourselves into the three states of matter, that is solids, liquids and gases. We learned that in case of solids, the molecules are compactly packed in a way that the intermolecular spaces between them are very, very smaller. And that is the reason why the intermolecular forces gets really stronger and it becomes really difficult to separate those molecules from each other. But in case of liquids, they have got the molecules of matter arranged in such a way that there is not much space between them, but yes, there is some space between them, there is some intermolecular space, and that's how the intermolecular forces are reduced to a certain extent when compared to the solid state. In case of gases, the molecules are really free, intermolecular spaces are quite large, and that's how the intermolecular forces are really weaker. And these molecules, just because they are free, they keep moving randomly from one place to another place. Depending on this, we studied that the solids have got their own shape. Just because the intermolecular spaces are smaller, but there are some there are stronger forces of intermolecular attraction. The molecules in case of liquids, they stay together, and that's the reason why they acquire the shape of the container. If you talk about a gas, there is no shape for that. It again acquires the shape of the container, but then these molecules will be randomly moving inside. So that is what we discussed about it. Now let us get introduced to one of the concepts that is called as diffusion. Basically, diffusion means movement of something or substances or molecules from one region of higher concentration to a region of lower concentration. I'll give you a best example. What we basically do is, we keep the incense stick, agarbatti, in one of the corners of the room. If you want the fragrance to spread, we will keep it in one corner. What basically happens is, the air particles which are there around the incense sticks will take up the aromatic molecules, okay? And in that particular region where the incense stick is placed, the concentration of the aroma particles get higher, right? The concentration increases. And as a result, what will happen? The molecules of those aromatic compounds will start moving from a region of higher concentration to the whole room where their concentration is low. This is a simple example of diffusion. So basically, diffusion happens in case of different states of matter too. How? We studied that in between the molecules of the matter, whether it is any state of the matter except the solids, it will become difficult in solids just because the molecules are tightly packed. In case of liquids and gases, just because the intermolecular forces are weaker when compared to solids and there are more intermolecular spaces, if you try dissolving anything, for example, if you take a liquid, okay, in which the molecules are arranged, but they are not arranged with so much of intermolecular forces between them. Now these spaces which are there, these spaces will help them to diffuse the different materials in them. For example, if I put one more liquid, these intermolecular spaces which are there, they will become sufficient for this liquid to come and occupy this space, and as a result we see that the liquids easily diffuse in the other liquid. So in case of a liquid, we see that either any other liquid or a gas can easily get diffused. It's all because in both the liquids, the liquid which is getting added and the liquid in which the liquid is getting added, both of them have less intermolecular forces and more of the intermolecular spaces, and those spaces, the diffusion can happen easily. And the same thing with the gases also. Anyhow, in gases, the intermolecular forces are really weak, the intermolecular spaces are high, more, That's the reason why the gases can come and simply get diffused in any liquid. Now, this property of diffusion really helps the life to exist on Earth. When I talk about the diffusion of gas in a liquid, to take an example, we have oxygen and carbon dioxide. These two are the gases. We know that these two gases have the capacity to get diffused into the liquid, that is water. We studied that fish, they have gills, and gills are specialized to take up the oxygen, dissolved oxygen that is there in the water. That means the gases in the atmosphere, that is oxygen and carbon dioxide, they diffuse in the water, and once they are diffused into the water, that same oxygen can be taken up by the fish, which helps the fish to live in the water. So this property of diffusion of gases into liquid, it is highly important for the life to exist, like at least aquatic life to exist on the earth. Coming to the last part, that is gaseous state. Now this gaseous state is again really helpful for us. Okay, now the different examples of gases that we use in our daily life, okay, which we can preserve and use it. Basically, we go with the mixture of gases, that is the air, wherein we take up air rich in oxygen, exhale the air rich in carbon dioxide. That is common. Coming to the special thing, we have LPG cylinders at home, which is liquefied petroleum gas. That means it is a gas which has got liquefied and it is there inside the container, the cylinder. Next one, oxygen cylinders that are used in the hospitals. And the next one is CNG, that is again a cleaner fuel which is used in the automobiles, which is nothing but the compressed natural gas. So these are the three examples of gases which are highly important nowadays in our daily life, without which we cannot even think of the life. Can we think of life without LPG? Okay, induction stoves will work. Again, so much of usage of electricity will make it really difficult to be used in our daily life. So again, LPG becomes the best option for us. And CNG is very important because it is the cleaner fuel. If we switch to the other fuel, any other gas, LPG also can cause a little bit of smoke. But this CNG it is actually a cleaner fuel which produces very less air pollutants. So these are the different examples of gases that we use in our daily life. Now I know that there are three states of matter. One is solid, another one is liquid, another one is gas. Now the question arises, can I make solids to become liquids and liquids to become gas and gases to become solid again? There arises a question. Let us see if they can be interchanged from one state to the another state. So, if we talk about the solids, I want the solids to change to liquids and the liquids to change to gases, gases to change to liquids, and liquids to change to solid. Some of the processes we are already aware of it. Now let us explore deep into this. Get into deeper of this concept and try understanding this in depth. Basically, the changes in the states of matter can be brought with two particular Okay, it can be brought with the help of temperature and pressure. Let us first explore what happens whenever the temperature is changed. Okay, what happens to the different states of matter? Whenever the temperature is changed, let us explore what happens to the different states of the matter. Let's take a simple example. We are aware that the water can exist in three different forms. That is solid ice, liquid water, water vapor as the gaseous state. Taking the solid, which is the solid ice, water form, if I take that ice and start heating, what will happen? It will start melting, right? The process of conversion of any solid into liquid is called as melting. Now this melting is also referred as fusion. It is also referred as fusion. If I talk about the melting of the solids, these solids melt at a different temperature. For example, the melting of the iron can be achieved at a different temperature. The melting of the ice can be achieved at different temperature. The melting of chocolate occurs at different temperature. All these are solids, but they're not melting at the same temperature. It becomes really difficult if they all are melting at the same time. So these solids, when they want to melt, they want to have a different temperature, right? So the temperature at which the solid melts and gets converted to liquid is called as melting point. The temperature at which a solid melts to become a liquid is called as melting point, and here we have to keep the pressure constant, that is atmospheric pressure. So we say that the temperature at which any solid melts to become a liquid at atmospheric pressure is called as melting point. Now talking about the melting point of the ice. Ice melts at 0 degree Celsius. You may have a question now as, how come, ma'am? 0 degree Celsius ice becomes, the water becomes ice, no ma'am. Then how come that the melting point of the ice is 0, ma'am? At 0 degree Celsius, if you see, no, you can find both the states of matter, that is ice as well as the liquid water, because some of the ice at 0 degree Celsius it melts, and some of the ice at 0 degree Celsius it starts to freeze. So 0 degree Celsius is the melting point of the ice. Now if I take this ice out at 0 degree Celsius and start heating it, that means I'm going to increase the temperature. Okay, I'm going to learn now what happens when the temperature is increased on the solid. Whenever I take an ice cube, put it in a container, start heating it, I know that it starts to melt. But there, I can see one thing happening. What is that? Though the ice is obtaining the temperature is increasing and the ice is getting converted to liquid, the temperature of the liquid remains same. It will remain cool only, right? In the initial stages, it will remain cool only. Now, why is the temperature remaining constant? Is the question. Now, think that if this is the solid which I had taken, which is having the molecules like this, which are compactly packed molecules. Now, if I want these compactly packed molecules to move apart from each other and this solid to get converted to liquid, I have to make sure that the bond between them which is there, it has to be broken, right? So all the temperature, that is the form of energy, the heat which is provided in the form of energy, that energy will be taken up by the molecule to break the bonds between the molecules, to overcome the intermolecular forces of attraction. So once the intermolecular forces of attraction are over, they are broken, the molecules have got separated, they will simply get converted to the liquid. Now, the heat which is taken up by the ice molecule to get melted, it is hidden in the ice cube. Now, that hidden heat is called as latent heat of fusion. We call it as latent heat of fusion. Remember, fusion is nothing but melting. So, latent heat of fusion is nothing but the amount of heat that is required to convert 1 kg of solid into liquid at atmospheric pressure. So, The latent heat of fusion is the amount of heat required to convert 1 kg of solid into liquid at the atmospheric pressure. Due to this latent heat of fusion only, the intermolecular forces of attraction, they get over and the molecules are set free at a little distance, and that's how the solid gets converted to the liquid. Now, if I talk about the ice which has slowly started to melt now. Now when the ice starts to melt, I could see two states of matter over there. The first state is the solid ice and the second state will be the water, which is having more energy. I'm not talking about the heat now, I'm talking about the energy. Is it the ice which is having more energy or the water which is having more energy when it is there in the initial stage of the melting? Obviously, it is the water, because ice is obtaining the energy to get converted to the liquid. That means the energy which is absorbed by the ice is now there in the water. That means at the same temperature, the water during the melting process will have more energy when compared to the ice. This is what we have to keep in our mind, because this concept we have to apply it in the next concept. So, whenever the temperature is increased for a solid starts to melt. Different solids melt at different temperatures. So, the temperature at which the solid melts at atmospheric pressure is called as the melting point. For the water, the melting point is 0 degree Celsius. So, once you start providing the heat to the solid and it slowly melts, the energy which is provided, it gets hidden in the system. So, that hidden energy is called as latent heat of fusion. This latent heat of fusion is nothing but the amount of heat required to convert 1 kg of solid into liquid at atmospheric pressure. Keep this in mind. For both the processes, I'm using the word at atmospheric pressure. That means I'm not having the pressure change here. I'm neither increasing the pressure nor decreasing the pressure. Pressure has to remain the same, only the temperature is getting changed. So that is all about the fusion. Now, think in a container, I had taken the solid ice, I was providing the heat. Right? I was providing the heat through some source. So what will happen first, the ice cube which is there, it will slowly start to melt and get converted to liquid, and after a few minutes I could see that the whole ice is melted and completely water will remain in the container. Now if I further provide the heat, if I further keep increasing the temperature, that means now I am increasing the temperature for a solid, for a liquid. Now this liquid, initially what will happen, I could get to see that the vapors will start coming up. Okay, vapors will start coming up, but the water will not start to boil, right? So this process which happens at the surface of the liquid before the liquid starts to boil is called as evaporation. Done? First, what will happen? When you increase the temperature of a liquid, the surface particles of the liquid will start converting themselves into a gas, a water vapor. Okay? So this conversion of a liquid into the vapor or the gas form before reaching the boiling point. I told you that the boiling point is not reached. So before reaching the boiling point, it is called as evaporation. Evaporation is the surface phenomenon. It will not happen in the complete liquid. Only the molecules from the surface of the liquid which are really heated up, which are having more heat energy, will simply overcome the forces of attraction between the molecules and they start moving as gas form. This is called as evaporation. Evaporation is the process in which the surface molecules of the liquid will start converting into gas before the boiling point of the liquid is reached. Now the question arises as, what is boiling point? Boiling point is nothing but the temperature at which a liquid starts to boil at atmospheric pressure. Again, I'm not changing the pressure. Pressure is neither increased nor it is decreased. At the atmospheric pressure, whenever the temperature makes the liquid to get converted into gas, that particular temperature is called as boiling point. Now, for different, liquids, the boiling point will be different. If I talk about the water, the boiling point of water is 100 degrees Celsius. Now, before 100 degrees Celsius is reached for the water, evaporation will take place. Once 100 degrees Celsius is reached, the molecules of the whole liquid, they get more energized, okay, and the kinetic energy of the molecules increase. What is the meaning of kinetic energy here? You are already aware that kinetic energy is nothing but the energy possessed by the moving molecules. I know that whenever I get something which I'm in need, I get super excited. I will not sit in one place. I will start moving here and there, here and there, here and there. The same way here also, the molecules, they want themselves to be set free. It is like freedom for them. When you provide the heat, intermolecular forces will be over. They are no more there to hold these molecules and they are free. In that hyper energy, their kinetic energy increases and they start moving randomly. And when they start moving randomly, obviously the liquid molecules, they get converted to the gas molecules. So after a certain time of evaporation, once the boiling point is reached, all the molecules in the liquid, they acquire more kinetic energy and start moving randomly, and then the boiling occurs. The boiling occurs. During boiling, what will happen? In the bulk of the liquid, all the molecules will start moving randomly and they start converting themselves into the vapor form. Now, the later stage, after evaporation, what happens is called as vaporization. So, vaporization is nothing but the movement, the conversion of liquid into the vapor form once the boiling point is reached. Before the boiling point, it is evaporation, surface phenomenon. After the boiling point, it is vaporization, bulk phenomenon, right? So, whenever the temperature of the liquid is increased, first evaporation will take place, and then at the onset of the boiling point, vaporization will start. Now, when the vaporization is happening, okay, I could see two states of matter again. One is the vapor form of the liquid and then the liquid form of the liquid. Now tell me, which form of the matter here will have more energy? Again, whenever I am providing the energy is obtained by the molecules of the liquid. They overcome the forces of attraction. That means they utilize the heat energy to overcome the forces of attraction between them, and then they'll set themselves free. So that energy which is absorbed by the liquid, it is now there with the vapor, right? So that is the hidden energy which is there in the vapor. That means at the same boiling point or the temperature above the boiling point, the vapor will have more energy when compared to the liquid. Now this energy which is there in the vapor is called as latent heat of vaporization. Latent heat of vaporization. Now this latent heat of vaporization can be defined as the amount of heat required to convert 1 kg of liquid into its vapor at the atmospheric pressure. Again, pressure is not changing, it is remaining constant, neither increase nor decrease in the pressure. Whenever 1 kg of liquid gets converted to the vapor form, that temperature is called as latent heat of vaporization. You may ask the question, ma'am, liquids are measured in terms of liters, ma'am. What are you talking about? You're talking about kgs. Yes. Liquids also can be measured in terms of kilograms, that is kgs possible. If you talk about the water, exactly 1 liter of water is equals to 1 kg of water. Okay? Whenever you want to convert the kg into liquid or liquid into kg, you have to get to know the density of the liquid. We know that different liquids will have different densities. Densities is nothing but if I take a unit volume of any substance, how many molecules are there? If in this particular molecule, unit area, unit volume, if there are more molecules there, the density is high. If there are less molecules, the density is low. So, whenever you want to convert the liquid into kgs, you have to make sure that you know the density of the liquid. Any liquid which is having the density equal to the density of water will be measuring like this. 1 liter will be equal to 1 kg. So 1 kg of liquid, the temperature at which 1 kg of liquid gets converted to gas is called as latent heat of vaporization. Due to this latent heat of vaporization, you see that the steam becomes really powerful. You might have seen whenever we are cooking in the kitchen, no? You take out the lid of the container. It is not the water which is there in the lid which hurts you. It is the steam which comes out that is hurting you. Why? Because at the same temperature, when both liquid and vapor is available, vapor will have more energy when compared to the liquid. That's the reason why liquid hurts is less, but the gas, the steam which comes out will be hurting more. Clear? I hope it is clear till here. That is latent heat of vaporization. So with this, we are done with the effect of temperature on different states of matter. A very short concept, that is nothing but what happens when you increase the pressure on the different states of matter. In the previous video, we learned that the solids which are there, they are non-compressible. Okay, we cannot compress them. For the compressing to happen, we require the pressure. Just because the molecules of solids are really packed very close to each other, it is very difficult to apply the force, and make them move further closer. And that's the reason why we'll not be able to compress the solids. But what will happen if you simply apply the pressure on the liquids or the gases? Let us first see this, okay? Let us take an example of a gas. For example, carbon dioxide. This carbon dioxide, I know it is a gas and it will have very less intermolecular forces of attraction and more of intermolecular spaces. So what will happen? You decrease the temperature. Here, whenever we want to do this process, whenever we want to increase the pressure and bring some changes into the states of matter, we have to make sure that the temperature goes down, okay? So bring the temperature down and increase the pressure on carbon dioxide. It will get converted to a solid. It will get converted to a solid. Now this solid is called as dry ice. This carbon dioxide under a very high pressure, when the temperature is reduced, it will get converted to the dry ice. Now this dry ice is basically stored under high pressure. The moment you release the pressure and you leave this dry ice open, no, just because the pressure was really high and you are suddenly releasing the pressure, no, the molecules of this dry ice directly get converted from the solid form to the vapor form. So what is basically happen? A gas is getting converted to a solid and a solid is getting directly converted to the gas without the interchange into a liquid. This process is called as sublimation. Sublimation is a process where a gas is directly converted into a solid or a solid is directly converted to a liquid. So that process is called as what? Sublimation. Yes. So sublimation happens. Dry ice is nothing but the carbon dioxide which is stored under the really high pressure. Now, LPG that we talk about, that is a liquefied petroleum gas. Now, how am I converting this gas into a liquid? It's very simple. Again, increase the pressure and decrease the temperature. What will happen? Due to the increase in the pressure, no. When you decrease the temperature, the energy, kinetic energy of the molecules will go down. As a result, they'll not be able to move randomly. And when you increase the pressure, no, you are actually bringing the molecules closer. When you bring the gas molecules closer, it will acquire the shape of liquid, and that is how the gases are converted to liquefied forms. So LPG which is there inside the cylinders, it is stored at a very high pressure. The moment you release the knob of the regulator, the liquid which is there inside the cylinder, once the pressure is released, it will get slowly converted to the gas and it comes through the pipe and we will be able to use it in the form of gas. So that is about your LPG. Now, we studied that whenever the temperature is decreased and the pressure is increased, we can liquefy the gases. Or else we can compress the gases to store in the cylinders. For example, if you talk about CNG is a gas, but under high pressure it is compressed and it is stored in the cylinders. Oxygen cylinders that are used in the hospitals, the oxygen which is there over there can be liquefied by increasing the pressure to a little more extent, or else it can be stored in the container after compression as a gas itself. So applying the pressure on oxygen, the oxygen can be stored in the cylinder as gas in more quantity, or else it can get converted to a liquid and then stored in the cylinders. That is also possible. So whenever the temperature decreases and the pressure increases, we see that the liquefaction of the gases will happen or the gases will get compressed. This is all about the effect of temperature and pressure on the different states of matter. Let's continue in the next video.